Okay, today we're going to talk a little bit about naming chemical compounds, and this is from a really basic level. In chemistry, the field of naming chemical compounds is called nomenclature, so nomen referring to the naming kind of things. So nomenclature is all decided by an overarching body that's called IUPAC, which stands for the International Union of Pure and Applied Chemistry, IUPAC. So naming chemical compounds all comes about because of rules that people have agreed upon, sort of like our SI units. We have a standard set of units that we use for all of our measurements. We have a standard set of naming so that we all know what we're talking about when we see a chemical formula or we see a name. So there's a few different rules that your book talks about that I want to touch on briefly. And the first is, if you see an element that is from the left of the periodic table and an element that's from the right of the periodic table, then you have a metal with a non-metal. Remember, we talked about the difference of the different sides of the periodic table. So metals are to the left and non-metals to the right. So if you have a metal with a non-metal, and we'll talk about what type of bonding that is. This is an ionic bond. These are ionic compounds. We haven't talked about that at all yet, so I just want to briefly mention it there because we'll get into it later. But metals with nonmetals are pretty easy to name because it's the name of the element that's to the left, or the metal, with nothing really fancy going on. And then the root of the name of the nonmetal, so just the first part of the name, and because you're only using the root, then you still have to come up with an ending, and the ending is IDE. So all of these that have an element from the left side of the periodic table and an element to the right of the periodic table are all going to end in IDE. Okay, so one of the primary examples, and one that we've already seen, is NaCl. So Na, we learned, is what metal? Hopefully you said sodium. Sodium. And then the root for chlorine. Chlorine is our nonmetal. It's one of the halogens. The root is ClOr. So I basically took off the INE ending of chlorine, and I'm going to replace it with this IDE ending, so sodium chloride. Okay. We can do this with any metal and nonmetal. We could do something like MgO. Mg isn't one that we've talked about, it's magnesium. So the name of this is the name of the metal, magnesium. The root of the O, we know that O is oxygen, so the root for oxygen is just ox. So we took off the YGN ending and we end it with oxide, magnesium oxide. Okay, so the name of the metal, name of the nonmetal. So that's pretty straightforward for metals with nonmetals or ionic bonding. It gets a little more complicated when we have things that are just to the right of the periodic table, those nonmetals. So if we have a nonmetal with a nonmetal, this is what is called covalent bonding. Again, we're not going to get into this until later, but I'm just going to introduce you to the term. So when we have a nonmetal bonded to a nonmetal, then we have this covalent bond. Okay, and again, we haven't really defined chemical bonds, but it's just when two atoms are stuck together for some reason, and we'll get into the reasons for the attraction between these atoms. But this is just at the most basic level, so we can be learning vocabulary. Learning chemistry, like I've mentioned, is like learning a new language. So we need to all speak the same language when we're talking about these different symbols. So we've just started learning about the symbols, and now we're translating those symbols into words. So with our nonmetal and nonmetal, let's take an example like C and O. C is carbon, O is oxygen. There are two different ways that carbon and oxygen can combine together. You can have 1 carbon to 1 oxygen, or you can have 1 carbon to 2 oxygens. Now the CO with the 2 there, the 2 at the bottom here, the subscript tells you that there's 2 oxygens for every 1 carbon. And if there's no subscripts, that just means that there's 1 of these to every 1 of these. Okay. Now we've talked about CO2 quite a bit. When we talked about climate change, we know that that is carbon dioxide. So note the difference between this name and the names that we talked about up here with the metals and the nonmetals. The difference is this prefix, right? The prefix tells me how many of that element there are. Di referring to the 2. So what do you think then is going to be the name of CO? If not di for 2, maybe you're thinking mon or mono. And carbon monoxide should be fairly familiar to you as well. Carbon monoxide is very poisonous, and we have carbon monoxide detectors in our homes now because of this reason. And we'll talk about that later when we talk about poisons and toxicology. So you can see that we can distinguish between these 2 compounds just by the names alone. I know that they're going to have different chemical formulas because I have these different prefixes. Okay. So here's another example. I could have this guy, and I could have this guy. So N is nitrogen, O again is oxygen. When I put together a nonmetal with a nonmetal, and we know that they're both nonmetals because they're on that to the right of that stair step of metalloids. When we put them together, they form in a couple different ways. So we can have, and this one's going to mirror carbon dioxide. This is nitrogen dioxide. And now this one has to distinguish between the number of nitrogen I have. So the prefix di refers to 2, so we're going to put that in front of our nitrogen this time, dinitrogen. And now we need a prefix to tell me that there's 4 oxygen. The prefix for 4 is tetra, like tetrapod. Tetrapods are animals that have, or organisms in general, that have 4 limbs. Okay, so dinitrogen tetroxide. So it looks like we need to learn some of these prefix names in order to do this naming. It's a little more complicated than our metals with nonmetals. So let's talk about these prefixes here. If you go on to higher levels of chemistry, then you'll probably have to learn a lot more of these, but for our class, I just want us to know 4 of them. So 1 is mono, 2 is di, 3 is tri, like tricycle, 4 is tetra. Now again, you could learn prefixes all the way up to 60 if you needed to, but for our purposes, we're just going to be looking at compounds that are fairly consistent, that are pretty smallish. So let's talk about a couple common names for some of these things as well. So if I was to name this compound, for instance, which is familiar, if I was using my rules, my IUPAC rules, I would call it dihydrogen. Dihydrogen monoxide. Okay, so the prefix tells me how many of that element there are. The prefix tells me of how many of that element there are. Dihydrogen monoxide. But we know that there's a common name for this compound, and it is water. So there are a few compounds that have common names that are more used, or more commonly used, than the chemical names. And the reason for that is they've been around for such a long time. Another example of this is NH3. And we'll learn a lot more about NH3 later on when we talk about things like fertilizers and World War II, actually. But the name of this thing, there's only one of these nitrogens, so it's nitrogen. And then there's 3, so our prefix for 3 is tri. Hydr is my root for hydrogen. And then we end in IDE, nitrogen trihydride. The common name for this is ammonia. You've probably interacted with ammonia before. It's the primary component in many household cleaners. I think about it like the smell of Windex. It can be quite strong when concentrated. Another one that has a common name is one that we've run into. When we talked about climate change, we talked about one of the greenhouse gases, CH4. If I was looking at the chemical name for this, it would be carbon, tetra, for my 4 here, hydride. Carbon tetrahydride, but that's not actually the name of this thing. The name of this thing is methane. Okay, so these are 3 that I want you to know the common names for, because these common names are the ones that are in common usage. You're not going to see dihydrogen monoxide. You're not going to see nitrogen trihydride. Although you will see, more often than not, every year or so, they put out a petition for something like, think about Moses Lake. If we were going to put a petition out to tell people about the dangers of all of the dihydrogen monoxide that's in Moses Lake, we need to shut the thing down. It's full of dihydrogen monoxide. And you get thousands of people that sign off on these petitions because they don't realize that that's the chemical name for water. That kind of speaks to this fear about chemistry, fear about chemicals. It looks like a chemical name, and so it's got to be bad. So I'm going to address some of those things, but this is just kind of the part of the naming part of this that I wanted to mention. So in terms of rules for this, you use a prefix if there are more than one of the first element. Otherwise you don't, right? I didn't say mononitrogen or monocarbon. If it's just one of the first element, then I just leave it as the element name. If there's more than one, then I have to include the prefix there, okay? You will always include the prefix for the second element, at least as far as we're concerned, okay? Now the third class of naming is something that your book mentions, and we're going to get into some of these compounds in a little more detail later, but they involve polyatomic ions. Polyatomic ions. Now we haven't talked about ions at all yet because we haven't talked about subatomic particles, but ions are charged atoms. Charged atoms, which means that they're atoms that have a charge on them, whether it's positive or negative, and we'll talk about that later. Now the polyatomic part here, poly means many, so this is many atoms grouped together with a charge on it. That's a polyatomic ion, and there's specific ones that I want you to know. When you have a polyatomic ion, these polyatomic ions are going to be made up of nonmetals, okay, and the group of nonmetals has a charge. And that group of nonmetals with the charge on it is going to be attracted to metals that have an opposite charge. So the rules for naming with polyatomic ions look very similar to that first rule that we talked about, metals with nonmetals. In this case, it's metals with a group of nonmetals, and that's our polyatomic ions here. So there's certain polyatomic ions that I want you to know, and then to name these things, it's just the name of the metal again, name of the polyatomic. It's actually the easiest, because you don't have to worry about the word root, you don't have to take off endings or anything, it's just the name of one, name of the other. And so there's specific ones that I want you to recognize. If you have CO3 that has a 2- charge, so this is the way that it's represented. The charge goes up here as a superscript. And remember that the subscript down here tells me how many of that element that it follows are in this particular grouping. So this is a carbon with 3 oxygens. The whole thing has a 2- charge. Okay, so the name of this polyatomic ion is called carbonate. Carbonate is really important. It's involved in a lot of different types of chemistry. Calcium carbonate is usually the go-to example for this. Name of the metal, calcium. Name of the polyatomic, carbonate. Calcium carbonate is the primary component in chalk. It's kind of a chalky substance in general that's used for a lot of different things. It absorbs a lot and all that kind of stuff. Another one I want you to know is NO3, so nitrogen with 3 oxygens. The charge on that one is a -1, so you just have this minus sign representing the -1 charge of this group of nonmetals. The name of this polyatomic ion is nitrate. So if we have KNO3, for instance, which we'll talk about when we talk about explosions in more detail, and we have K, which is potassium, potassium nitrate, name of the metal, name of the nonmetal, or name of the polyatomic in this case. Potassium nitrate. Okay. Another one that's going to be important that I want you to know is OH with a -1 charge. This OH together is called hydroxide. Hydroxide. There's a lot of important compounds that have hydroxides. This is going to be really important when we talk about acids and bases later on in the quarter. One of the go-to example compounds for this is sodium hydroxide, which is also called lye or caustic soda if you've worked in industry before. So these are 3 that I want you to know. There's another one that's going to be important later on when we talk about toxicology, and that's cyanide. Carbon with nitrogen with a 1- charge is the cyanide ion. And there's an incredibly toxic to us gas called hydrogen cyanide, HCN. And this gas is incredibly poisonous. This doesn't really work with my metal and non-metal, or metal and polyatomic, because hydrogen is a non-metal, but this is one compound that contains the cyanide ion that you might run into. Okay, so that's it for polyatomic ions. That's it for naming. If you have any questions on this, then just let me know.